Hi there. In this lesson, we're going to add a sensor, which is a light sensor. So this sensor will allow us to perceive the amount of light that is within this room right now. So we're going to add this sensor over here. We are going to add this sensor over here, the light sensor. If you have doubts on which sensor to take, I advise you to go through the video we made of the kit. So we are going to hook it up to analog pin 0, this one. And we are going to open another example. Examples, analog, in-out serial. This is one of the most complex, powerful, interesting, full of new things, new cool stuff. We're going to set up an analog input pin, which is A0. We're going to set up an analog on output pin, but we have to redefine it as pin 5, which is the pin we used previously to hook up the push button, remember? I verified. Then we have two variables. One is used to store the value of the sensor. The other is used to store the output value of the sensor. Within the setup, we are not doing anything other than declaring the beginning of the serial communication at a specific speed, 9600. So we do have an LAD, but we are not asked to declare it. We could declare it, but we are not obliged to because we are controlling it with another function which is not digital write, but it's analog write. So at the very beginning of the loop, we analyze, we listen to the value of the analog pin throughout the AnalogRead function, and we pass it to the sensor value. This value is going to go from 0 to 1024 because the resolution of the analog to digital converter, so the resolution of the analog reading device within the Arduino board is 10-bit. So 2 elevated to 10 is 1024. What happened is that since the output we are sending is as just 8-bit resolution, so 256, we have to map the two values. We map the two values by using a map function. The map function is a very powerful function you're going to use in many situations, and is satisfied by 5 different values. The name of the value, its minimum and maximum level, and the minimum and maximum target resolution you want them to reach. So, in other words, if you want to listen to 0 to 1024, to 1023, and you want to map it to another spectrum, which is tighter, you are going to use the map function as we are doing here. So the output value takes the sensor value and remap it to this lower resolution. And then using the AnalogWrite function, we are writing on this output pin the value that we are reading on the LDR, on the light sensor. Interestingly, we are also using this new thing, which is the serial port. We use the serial port to read through this data. So we are going to open this serial port and read the data that we are reading, that Arduino is reading. So we upload it to the board. So when we upload it, we are going to open the serial port pressing this button over here. I'm going to take off my camera. So you can open by pressing the serial monitor or under tools, I guess, serial monitor. Okay, I'm going to open it using this. This is a serial port. And this is how it's changing. You see, the LED is almost turning off. And if the light goes on, the LED is turning on. So actually, the LED represents the amount of light that we are experiencing in this situation. I guess I can also switch on the LED on top of my camera, so you can see a dramatic change of data. So actually, we could write an Arduino sketch that tells me if the amount of light in a specific room turns on. So we are able to trigger experiences based on the presence of people in a room. So in today's lesson, we have seen the serial communication. We have seen in action the map function based on the example we found in the analog section called analog in, analog out. We have seen also the combined use of AnalogRead and AnalogWrite. See you in the next lesson.